Welcome to Space in Minutes, where space meets simplicity. New videos drop weekly, so subscribe and join our awesome cosmic community. If you're excited about making space more accessible for everyone, why not join us as a member? Your support really means everything to us. As a member, you can enjoy our videos without ads and help us create even more awesome content. The universe is vastly unlikely full of life. So, where's everyone hiding? In the 1950s, physicist Enrico Fermi looked up at the stars and asked a simple yet profound question. Where is everybody? With billions of stars in our galaxy alone and billions of planets orbiting those stars, it seems almost certain that intelligent life should exist somewhere else in the cosmos. Yet, despite our best efforts, we found no signs, no signals, no visits. Nothing but an eerie silence. This puzzling contradiction is known as the Fermi Paradox, the stark contrast between the high probability of extraterrestrial civilizations and our complete lack of evidence for their existence. It's a mystery that has captivated scientists, philosophers, and dreamers for decades. Today, we're diving into some of the most fascinating, bizarre, and scientifically grounded ideas for why the universe feels so empty. Let's start with a mind-bending possibility. Maybe life is incredibly rare. We often assume that life, especially intelligent life, is common throughout the universe. But what if Earth is uniquely suited for life, a rare gem in a vast, mostly inhospitable cosmos? This idea is known as the rare Earth hypothesis. It suggests that while microbial life might be somewhat common, the evolution of complex, multicellular organisms could be extremely unlikely. There are several factors that might be critical for the development of advanced life forms. First, you need a stable climate over billions of years. Earth has maintained relatively consistent conditions for an incredibly long time, allowing life to evolve and diversify. Many planets aren't so lucky. Then there's the presence of a large moon. Our moon helps stabilize Earth's tilt, preventing wild climate swings that could make complex life impossible. Without it, our seasons might be chaotic and unpredictable. Tectonic activity is another crucial factor. It helps recycle carbon and other essential elements, maintaining a balance that's vital for life as we know it. Many planets might be geologically dead, lacking this important process. Strong magnetic field is also essential. Deflects harmful solar radiation, protecting life on the surface. Without it, even if life emerged, it might never progress beyond simple, radiation-resistant microbes. Finally, you need the right kind of star in the right part of the galaxy. Too close to the galactic center, and you're bombarded with radiation. Too far out, and you might lack the heavy elements needed for planet formation and life. Even with all these factors in place, intelligent life took 4 billion years to evolve here on Earth. It might not be a universal outcome, just a rare fluke of cosmic chance. Think of it like finding a perfect pearl inside a specific kind of oyster in a specific part of the ocean on one particular day every few million years. The odds are astronomical. But what if life isn't rare? What if the reason we see no one is because most civilizations never make it past a certain point? This brings us to our next theory, the Great Filter. The Great Filter is a proposed stage in evolution that is incredibly hard to cross. It could be behind us like the origin of life or the development of multicellularity, or ahead of us in the form of some existential threat that most civilizations fail to overcome. If the Great Filter lies in our past, it would explain why we don't see anyone else out there. We're the lucky ones who made it through. But if it lies ahead, it suggests a grim fate, not just for alien civilizations, but potentially for us as well. Possible filters include the very origin of life itself. Maybe the leap from non-living chemistry to self-replicating organisms is incredibly rare. Or perhaps the development of intelligence and technology is an unlikely outcome of evolution, happening only in the rarest of circumstances. But the most unsettling possibility is that civilizations tend to wipe themselves out. This could happen through devastating wars, the development of artificial intelligence that spirals out of control, or environmental collapse brought on by unchecked growth and resource consumption. Think of it like an obstacle course with one nearly impossible wall to climb. Most runners don't even know it's there until it's too late. If the great filter lies ahead, it would explain the silence, suggest a sobering challenge for humanity's future. But let's consider a more optimistic possibility. Maybe aliens are out there and they know about us but choose to remain hidden. This idea is known as the zoo hypothesis. The zoo hypothesis suggests that advanced civilizations have a sort of prime directive, avoiding contact with less developed species to preserve their natural evolution. They could be watching us, studying our development, waiting for us to reach a certain level of technology, ethics, or galactic maturity before initiating contact. Imagine humans walking through a wildlife reserve. We observe animals, study them, but we don't tap on the glass or interfere with their world. The zoo hypothesis is true. Earth might be like an exhibit in a cosmic wildlife reserved but untouched. This idea is both comforting and unsettling. On one hand, it suggests we're not alone and that there are benevolent, advanced civilizations out there. On the other hand, it means we're effectively trapped in a cosmic petri dish, our fate potentially in the hands of unseen observers. But what if alien civilizations are trying to communicate and we simply can't detect them? This brings us to our final theory, the possibility that our search methods are fundamentally flawed. Even if the galaxy is teeming with intelligent life, we might not recognize their signals. They may use communication technologies far beyond our understanding methods we can't even conceive of, let alone detect. Or perhaps they're using signal types that decay before reaching us, making interstellar communication effectively impossible over vast distances. Another possibility is that they're using tight-beamed messages aimed at specific stars, rather than broadcasting omnidirectionally. If that's the case, we might simply be missing these focused transmissions. It's like trying to listen to a modern podcast using an ancient AM radio, or tuned to the wrong frequency or using the wrong device altogether. Our search for extraterrestrial intelligence might be fundamentally limited by our own technological constraints. It's also possible we're looking at the wrong timescales. Civilizations may only broadcast for a brief period before switching to undetectable methods. We might have missed them by hundreds or thousands of years, or we might be too early, with the galaxy's communication networks yet to come alive. The Fermi Paradox remains one of the most intriguing mysteries in science. Are we alone? Are we rare? Are we being watched? Or are we simply not looking in the right way? Each possibility carries profound implications for our understanding of life, the universe, and our place within it. As we continue to explore our cosmic neighborhood, develop new technologies, and push the boundaries of our understanding, we edge closer to potentially answering Fermi's question. Till then, we are left to wonder, to theorize, and to look up at the stars with a mix of hope and curiosity. The next time you gaze at the night sky, remember, the answer to where is everybody. It might be out there, waiting to be discovered. Or perhaps, in our quest to find others, we'll come to a deeper understanding of just how precious and unique our own world truly is. The universe is vast beyond comprehension. It's a concept that's hard for our human minds to truly grasp, but let's try to put it into perspective. Even the closest star system to us, Proxima Centauri, is over 4 light years away. That's a staggering 40 trillion kilometers. To put that into context, if we were to use our current technology to travel there, it would take tens of thousands of years. Just imagine setting out on a journey that your great-grandchildren's single quotes as children might complete. Now, here's where it gets interesting when we think about alien civilizations. Even if they exist out there, interstellar travel might be too difficult, too expensive, or simply not worth the effort for them. It's entirely possible that we're all stuck in our own cosmic neighborhoods, unable to reach out and touch each other. Think of it like this. It's like trying to shout across the Pacific Ocean. Your voice, no matter how loud, fades away. The distance is just too great, and nobody on the other side can hear you. That's the reality we might be facing in our search for extraterrestrial life, but it gets even more complicated. What if advanced civilizations are using non-expanding probe networks? Or what if the speed of light truly is an unbreakable barrier? These factors could make it even harder for us to detect signs of life out there. It's no wonder we haven't seen any evidence of aliens yet. Now, let's consider another possibility. What if we're early to the cosmic party? Maybe we're one of the first intelligent civilizations to emerge in the universe. It's a mind-bending thought, but consider this. Stars and planets will continue forming for trillions of years. Our Earth, in the grand scheme of things, might just be an early bloomer in the cosmic timeline. If intelligent life takes a long time to evolve and spread across the galaxy, we could be part of the first wave. We might even be the very first intelligent observers in our entire galaxy. It's a humbling and exciting possibility. Here's an analogy to help you picture it. Imagine arriving at a concert venue long before the doors open. The parking lot is empty, the stage is quiet, and you're wondering where everyone else is. But the truth is, the crowd just hasn't shown up yet. That could be us in the cosmic concert of life. This idea isn't just wild speculation. It's actually some scientific backing to it. Conditions for life may actually improve in the future universe. We're talking about longer living stars, more stable climates, and planets richer in metals. The stage for life might be getting better, not worse, as time goes on. But let's take a sharp turn into more speculative territory. There's a fringe theory out there that suggests aliens might already be here on Earth, and we just don't recognize them. Now, before you dismiss this idea entirely, let's consider some of the possibilities that proponents of this theory suggest. They argue that ultra-advanced beings could be living among us, completely undetected. Or perhaps there are non-physical forms of life that we simply can't perceive with our limited senses. Some even propose that we might be living alongside simulated beings in a program that we can't access or understand. It's like we're characters in a video game, unaware of the players or developers outside our reality. Here's an analogy to help wrap your mind around this concept. Think of ants in a bustling city. These tiny creatures go about their lives completely unaware of the complex systems and structures that exist above and around them. In the same way, we might be oblivious to advanced civilizations or life forms that coexist with us on Earth. Now, it's important to note that there's no scientific evidence to support these ideas, but they do reflect something important: the limits of our imagination and our assumptions about what life might look like. We might be constrained by our Earth-centric view of biology and intelligence. The Fermi Paradox challenges everything we think we know about life in the universe. It forces us to confront some uncomfortable possibilities. It could mean we're truly alone in the cosmos, a sobering and perhaps frightening thought. Or it could suggest that there's some great filter or danger that awaits intelligent life as it develops, preventing civilizations from reaching out across the stars. On the flip side, it could mean that the universe is actually teeming with civilizations, just not in ways we can see or understand with our current technology and knowledge. The possibilities are as vast as the universe itself. Here's one last analogy to ponder. Imagine entering a vast, ancient library. The shelves stretch as far as the eye can see, promising untold knowledge and stories. But as you approach, you realize all the books are locked behind impenetrable glass. You can see the wealth of information, but you can't access it. That's the frustration and wonder of the Fermi Paradox. In every case, in every theory we consider, the Fermi Paradox reveals one fundamental truth. The more we search for answers, the more we realize how little we truly know about our place in the universe. As we wrap up this cosmic journey, I want to encourage you to keep exploring these ideas. Subscribe to our channel for more deep dives into space, science, and the mysteries of the universe. We're always here to fuel your curiosity and spark your imagination. And hey, I'd love to hear from you. Drop your favorite Fermi Paradox theory in the comments below. Or, if you're feeling creative, share your own ideas about why we haven't found aliens yet. I make it a point to reply to every comment. So, let's get a conversation going. Remember, in the face of the universe's silence, we have two choices. We can feel small and insignificant, or we can feel incredibly special and unique. Either way, it's a reminder of how precious our existence is. So, stay curious, stay cosmic, and always remember the silence of the universe. It might mean something profound, just haven't figured out what that is yet. That's just one cosmic mystery explained in minutes. If you learned something new today, give it a like and let me know what you're curious about in the comments. I'll reply to every single one. And if you want to see more space, science, and imagination, all in under 10 minutes, subscribe for more. Thank you so much for watching. I'll see you next time. That's 1 minute. See you tomorrow.